Exponential functions. An exponential function is something that can be written of the form f of x equals a times b to the x. Find f of x if f of 0 equals 5 and f of 3 equals 40. Now there are two things we need to find here. We need to find a and b. Remember back when we've solved equations before, when there's two unknowns, we need two equations. So let's take a look here. We can plug in. This is giving us a point. Remember that this is a point 0, 5. The x value is 0, the y value is 5, and this would be the point 3, 40. Well, let's plug it in. We'll have 5 equals a times b to the 0. And what is b to the 0? B to the 0 is 1. So a equals 5. Now, whenever you're given a point f of 0, these types of things are pretty easy. Now we have the equation f of x equals 5 times b to the x, and our goal is to find b. So we can use the next point, 40 equals 5 times b cubed. So 8 equals b cubed. And then we're going to take the cube root of both sides. So the cube root of 8 is 2. Now we're not done yet because we actually need to write the equation. So f of x equals 5 times 2 to the x. Take a moment yourself and do this one. Stop it and then check to see that you have it right. So this would be 80 equals a times b to the 0. So a is 80. Now we have 5 equals 80 times b to the 4th. 1 over 16 equals b to the 4th. So that's 1 over 2 to the 4th equals b to the 4th. Now, when you're doing this and we take the 4th root of this, when we're doing an even root, we have a plus or minus on there. But b cannot be a negative number, so we have to take that negative and just throw it out. And so we'll have 1/2. So our equation this time is f of x equals 80 times 1/2 to the x. Notice I have parentheses on this. If I do not have parentheses, the only thing that's being raised to the x is the 1. So you need to write it notationally correct. Now we're going to talk a little bit about half-life. What does that mean? Think about that a little bit. Try to come up with this and then, so pause it again. All right, half-life is the time it takes for half of the amount of substance, I'm just going to call it substance here, to decay / we can think of this as go away. So when you're looking at that, no matter how much you're starting with, the half-life is always the same for any particular material. It is that fixed amount of time, saying whatever amount you have, you're going to have half of it in that amount of time. So let's take a look at an example with this. The half-life of some element is 600 years. There are 1,000 grams of the element now. How much will there be in 600 years? 600 is one half-life, and so we'll have 1,000 times a half, which will be 500. How much will there be in 1,200 years? Well, you can see that 1,200 is, we went 600, so we're going to go another 600, so we could take our 500 times 1/2. But instead of that, what we could also do is let's start from the beginning. From the beginning, we had 1,000. After 600 years, we had one half-life. And after another 600 years, we have a second half-life, or in other words, 1,000 times 1/2 squared. And I'm more interested in that process than I am in the specific number. And another thing we should do is label our units here. So these are grams. So what this is telling us is that we had 2 half-lives in this problem. Thinking in a similar way, how many half-lives are we going to have here? 2,400 years would be 4, because 2,400 divided by 600, so it means 4 times we're going to have multiplied by a half, and instead of writing all of that out, we can say 1,000 to the 4th. And when you do that, you get half of 125 and another half of 125, which would be 62.5 grams. We can do that one without a calculator. Now, what would it be in T years? We know we have 1,000, and we know it's going to be multiplied by a half to some power. How do we get this 4? How do we get this 2? We took 2,400 and we divided it by 600. How can we get the 2? We had 1,200 divided by 2, or 1,200 divided by 600, and we have our 2. So in general, we're going to take our number of years, and we will divide it by 600. Let me erase that to make sure it's clear. So T over 600. Now here's a slight variation of it. What happens if it is 300 years? Well, once we have this expression for the half-life, we can just plug it in. So we have 1,000 times 1/2 to the 300 over 600. Or in other words, just to the 1/2. Well, what is 1/2? Let's see about doing this right now, and how would we simplify that? Work a little bit on our simplification skills. That's a 1. A half is the same as a square root, so this is going to be 1,000 times 1 over the square root of 2, and that can rationalize to square root of 2 over square root of 2, which will give us square root of 2 over 2. So we get 500 times the square root of 2. So that would be the exact value. That is approximately 707.1 grams. All right, let's take a look at this next one. Here's an bacterial growth in some solution. Does an exponential model seem reasonable? Why? Before I do that, does a linear model seem reasonable? What has to be true in order for it to be a linear model or a linear function? Well, what we'd have to have is a constant growth, a constant increase. So if we increase by 1, for example, let's say the growth was 100, then every time we move over right 1, in this case in terms of hours, we would increase by 100. Well, let's take a look here. When we're adding 190, well, we're not adding 190 there, nor are we adding another 190, so a linear model is definitely out of the question here. What about an exponential model? What does that mean? When we're looking at, for example, this half-life, what are we doing every single time? We're multiplying by something. Well, let's take a look at what that, when we're thinking about multiplication, is there a multiplication factor that you could apply going to each one of these? So what we'd want to do is take a look. What's 450 divided by 260? That's approximately 1.731. I'll do the calculations for that. 780 divided by 450. And that one is approximately 1.733. 1350 divided by 780, and that is approximately 1.730. So does an exponential model seem reasonable for this? Yeah, it does. That seems like it would be a good fit. And so when you're looking at that, these numbers vary slightly, but they're approximately the same thing. So yes, now let's also take a look here when we're thinking about an exponential model. If I said f of x equals a times b to the x, that's what the first equation we wrote down. If I look at f of 1, what does that mean? That means a times b. F of 2, a times b squared, or in other words, a times b times b. And b is our multiplication factor that I was just talking about. So when I was comparing it to the linear model, in the linear model we'd move over some fixed amount, let's say 1, then it goes up. I gave the example of 100. In this case, when we move over on our number of hours, we have to multiply by that same value, whatever that value is. So now, in terms of doing this, find the equation for P of t, there's a couple ways to go about it, but what I want to do right now is you wouldn't really know exactly which points to use unless you were told that. And so I'm going to tell us to do, let's use the point 3, 260 and 6, 450. We'll use those two as our, just like we did on problem number 1 and 2. So in this case, we have P of t equals a times b to the t. Just a slight variation of our f of x. Let's plug it in, and we have 260 equals a times b cubed. And we have 450 equals a times b to the 6. Now, we have a system of two equations with two variables. Add subtract is not a method we can use here. We can do substitution. That would work. We could solve one of the equations for a, plug it into the other one. There's another one that works nicely for exponential functions, and that is when you see we have an equation here. That means 260 equals a times b cubed, and 450 equals a times b to the 6. So in other words, these two amounts, a times b cubed, is the same as 260. We can take this equation, and as long as we're dividing by the same thing to both sides, this is still going to be true. So let's take 450 equals a times b to the 6, and we're going to divide both sides by the other equation, 260, and I shouldn't have an equal sign here. In fact, I have one equal sign for the whole thing. I'm dividing by the same amount on each part. So now I can say 450 divided by 260 will just be 45 over 26 equals b cubed. Now, when I'm looking at this next part, I'm gonna put it on another piece of paper here. You can go on the next piece of paper or just section off. I just don't want to confuse anybody by moving it too much space there. So now I'm going to take the cube root of both sides, or I can write it as 45 over 26 to the 1/3. Either way is fine. What I'm going to do now is instead of actually finding an approximation for this, I want to leave it like that. I'm going to find my equation exactly. So I have two different equations here. I can plug it into either one. Which one do you think would be the best one? Well, let's look at the exponents. This is a 3 and this is a 6, and we have b here. Well, if I plug it into this one, the first one, then 1/3 times 3, that's going to be a simpler equation to deal with. So let's plug it in there. We have 260 equals a times this thing b over 226 to the 1/3 is being raised to the 3rd power. So the 1/3 times the 3 gives us 1. So this is a times 45 over 26 equals 260. And then we're going to multiply both sides by the reciprocal. So we'll get 260 times 26 over 45 equals a. Now, I'd want to keep this exact. So if you look at your calculator, the calculator is going to tell us it's 150.22222 with a bar. So we could use that. That's fine. And our equation is, now we're just going to plug it in. Now, this equation is not going to look nice, but that's okay. We have P of t equals 150.2 with a bar times 45 over 26 to the 1/3, all raised to the t there. That can be simplified just a little bit to 150.2, and then we have 45 over 26 to the t over 3. Now let's go and take a look at the second way. Let's look at these numbers here. When we came back here, we realized that we have basically the same multiplication factor. What is happening? So this realized we were an exponential, but look carefully at these other numbers. We have 260, and over here 780. What's 780 divided by 260? It's 3. What's 1350 divided by 450? It's also 3. So in other words, when we increase by 6 hours, the population is going to triple, which sounds a lot like the half-life problem. So what this method 2 will say, P of t equals a times 3 to the t divided by 6. Every 6 hours, this thing is going to triple. Now we could choose a point to find a. What would be the easiest point? Since this is divided by 6, I want to use the point 6, 450. So when we plug that in, we get a equals, or not a equals, 450 equals a times 3 to the 6 over 6. Or in other words, 450 equals a times 3. A equals 150. So this time my equation is 150 times 3 to the t over 6. Now how does that work when you have two different equations? Well, they're approximately the same. So they're not exactly the same, but the approximation are the same. And we're dealing with real numbers. That's going to happen. In general, when we take a look at this, we have this equation, y equals a times b dx, becomes a of t equals a sub 0 b to the t divided by k. Now what do all of these things stand for? A sub 0 is our starting amount, or our initial amount, whichever one you want to say. B is our multiplication factor. Now what is that? For a half-life, it would be a half. What if it were telling us we're going to double? Or it could triple, like the example we just did, and we saw that it tripled every 6 hours. Whatever that multiplication factor is, and then k is the number of years / time. It could be in hours, like in the previous example. It takes to be b times bigger. Or bigger is probably the wrong word. How about b times as much? B times as much, because on the half-life it is actually getting smaller. So for the following example, explain what each number means. Assume this is a bank account. So here it says we start with how much money is in the bank? $500. And it doubles every 10 years in this case. It wouldn't make sense to have hours. What if T is hours in population of bacteria? This says we start with 20 bacteria. That's here. And then what happens? It is 50 times bigger in how many hours? It's 50 times bigger in 9 hours. And that's what that number there is. And that's it.